associated with the projections. In general, all of those projections are called the vein. So the part of the feather the part of the shaft of the feather associated with the vein is the rachis. The part at the base that does not have the vein is the calamus. Well, what makes up the vein? The vein is going to have many projections coming off of it, coming off of the main axis, the rachis. Many structures called barbs. Right? So we're talking about what is forming the vein. Vein is made up of barbs that are projecting off of the shaft, specifically off of the rachis. Each of these barbs then has projections coming off it. The smaller projections are called barbules. So that could be my shaft. We'll blow it up and we have a barb coming off of it. And then coming off the barb, we have smaller projections, which are barbules. Right? That's where the feather is anchored in a feather follicle at the body, so that's the base of it. We will have barbules coming off both sides of the barb. And we can identify them. We can give names to those barbs on the different sides. So if it is away from the base of the body, it is the distal barbule. And if it is closer to the base or body, what are we going to call it?
Proximal.
Proximal, yes. All right, those two are always opposites of each other, distal and proximal. So you have the shaft divided into the calamus at the base and the rachis. Coming off the rachis, you have a large number of barbs helping to form the vein. Each of those barbs is going to have projections called barbules. We call the ones that are farthest from the body the distal barbules, and those that are closest are the proximal barbules. Now these are structured somewhat differently. In other words, the distal and the proximal barbules are somewhat different in the way that they are shaped. The distal barbules, have hooks on the underside. I'll show a diagram in a minute, but essentially if this is what we're talking about, we have hooks coming off of that barbule. Not the barb, but the barbule. That's the distal barbule has hooks. The proximal, though, has what most books would describe as a smooth flange. All right, this is my attempt at three-dimensional drawing. Well, you're laughing already. Stippling to indicate that it's back farther. So if you could think of it as a lowercase r, if you did a cross section of it, it would be something like that. But that top part of the r then is extending inwards and outwards and through the board, giving me this long flange. So distals have hooks and the proximal is more shelf-like, if you will, shaped like an R. The cool thing about it is that we end up getting distal and proximal barbules from different barbs overlapping. So this was actually a very good diagram to illustrate that point. What did I just do? Go away. Okay. So here's your rachis. Coming off, you have barbs. And then coming off the barb, you have barbules. So the center one is the only one in which they drew both the proximal and the distal barbules. So this is the base, this is the proximal. Here's my flange, my R shape and cross section. And then here's my distal coming out with lots of little hooks coming down towards the bottom of the page. Now look what happens, is that you have a distal barbule here with its hooks, and those hooks catch on underneath the flange of multiple proximal barbules, not just one. So if we look at, most of these are going to be 3, 1, 2, 3, 1, 2, 3. So those hooks are grabbing, a single hook is grabbing underneath that shelf. But that distal barbule has hooks that are going underneath the shelf of multiple proximal barbules. What that does is gives you a very strong, lightweight structure that resists deformity. Deformation either by pushing on it or because air pressure is changing. And you've all played with feathers at some point when you were 2 years old and 4 years old, and you know that the feather can look kind of messy, and by just drawing your fingers up along it, you can sort of zip it up and it goes back to its original shape. So if it looks weird, the vein looks weird, it's because you're not having the proper overlap of the proximal and the distal barbules. When you run your fingers over the feather, you are getting them back into the proper location so that they do overlap. It's that overlap of multiple distal and proximal barbules that gives you that strong, lightweight structure. Right, types of feathers. Got a number of different kinds based upon structural differences. So we know the basic anatomy of a feather, but we can modify that to give us feathers of different types, and sometimes they're going to have different functions. Veined or contour feathers, down feathers, semi-plumes, phyllo-plumes, or powder down. Okay. A veined or contour feather has the structure that I just described. So with these proximal and distal barbules overlapping in such a way to give you that firm vein. These are the feathers that form the outer covering of the body. So they're the feathers that form the outline or the contour of the animal's body, hence the name contour. They're veined because we have our overlapping proximal and distal barbules to give us a vein. But we can use the term contour just as well. They're the outer feathers that are giving us the shape of that animal. We can identify two different types. You'll see these particularly in descriptive works concerning birds, the retrices and the remiges. The retrices are the tail feathers. The remiges are the wing feathers. I'll throw in a third type here as well. Retrices, remiges, and coverts. We have the tail feathers, we have the wing feathers. Within the remiges, we also have a division into primaries, secondaries, and tertiaries. So primaries are remiges, wing feathers, that come off the hand. So this diagram that you have on handout 42. The primaries then are attaching to the hand bones, the skin covering the hand bones. The secondaries are attaching to the forearm. So you can see the radius and ulna in that drawing. You have your double forearm bone. Tertiaries aren't shown in that particular diagram, but I'm sure you can guess that they're coming off the upper arm. So the retrices are the tail feathers, the remiges are the wing feathers. The wing feathers can be primaries, secondaries, and tertiaries, just depending upon what part of the wing they're coming off. So it's going to be from the outer to the inner. The primaries are coming off the hand, the secondaries off the forearm, and the tertiaries then off the upper arm. So we have tail, we have the wing, and then we have coverts. These are smaller feathers. Same structure with the overlapping proximal and distal barbules, but smaller, and in effect they act as shingles. They cover over the base of the primaries, secondaries, and tertiaries. They cover pretty much the entire feathered part of the body of the animal. And they're overlapping like shingles would.
Could you repeat that last part about them covering the body?
Sure, so what coverts are going to do, they're going to cover things. What are they going to cover? Well, they're going to cover over the base of the primaries, because remember you have that calamus there, which does not have a vein associated with it. They're going to cover up that area, the primaries, secondaries, and tertiaries, the base of them. But they're also going to cover over the entire feathered body. So if you're going to pluck a chicken in order to eat it, the first thing you're going to start ripping off are the coverts, because they're the outside feathers that are determining that contour of the bird. These are the external layers. Okay. Down is different from a contour feather because we lack hooks on the barbules. And since we lack hooks on the barbules, we can't get that interlocking structure, the vein. And another characteristic of down is the fact that the rachis is shorter than the longest arm. So here would be my barbs coming off.